Okay, Theorem 1013. Relates to secant and tangents. Secants and tangents. So look, if you got a tangent right here, and then you got a secant. Tangent and a secant. We'll say that AB is your tangent, B to C is your secant. There's an angle that's formed, and it's formed right here. And this angle is called on the circle. Yesterday you dealt with angles that were inside the circle, because the chords and the secants intersected inside the circle. Today you're going to deal with angles that are formed on the circle and outside the circle. This is a case where the angle is formed on the circle. So if we call this angle 1 right here, alright, here's the rule, the measure of angle 1. The measure of angle 1 is equal to 1/2 arc CB. That angle, the red angle, is equal to 1/2 of the blue arc. Whatever the blue arc measure is, you divide it by 2, and it gives you the red angle measure. The angle formed by a tangent and a secant. Tangent and a secant, the angle is on the circle. When the angle is on the circle, the measure of the angle is half of its intercepted arc. That's one picture of it. Here's another picture of it. Here's a tangent. Here's a secant. Let's say your points are A, and you got B, C, and D. And you need the measure of angle ACD. ACD, that starts at A, goes down to C, and over to D. It's this red angle right here. Alright, that red angle is going to be equal to half of this arc. That is its intercepted arc. So if AC, arc AC, was equal to 178, alright, then you take 178, you divide it by 2. And 89 degrees would be this angle right here. Alright, this red angle, 89 degrees. So that's one way you'll be given the problem. Here's another way you'll be given the problem. FDC. Okay, so here's your secant. D to F is a secant. D to C is a tangent. You're given this angle, 64 degrees. And you're asked to find the measure. Arc DEF. And E is over here. The measure of arc DEF. Okay, so look, if this angle right down here is 64 degrees, then its intercepted arc, this arc that goes from F down to D, would be twice as big as the 64. So 64 times 2 is 128. But that's not what they're asking for. They're asking for the measure of arc DEF. This is DEF. It's the one that's around the back. So if you use the 64-degree angle to find this arc, well, arc F to D and arc DEF have to sum 360. So DEF is going to be equal to 360 minus the 128. 360 minus 128. That's 232. Here's a tangent and a secant. Your points are H, J, L, K, and you're given the angle of 116. You're asked to find the measure of JLK, the measure of arc JLK. So J through L and up to K is this red arc. This red arc is the intercepted arc for the 116. So JLK is going to be equal to 2 times the 116. And 2 times 116 is 232 degrees. Understand? Anybody confused? Tangent and a secant. The angle's half the arc. The arc's twice as big as the angle. Alright? Now look, these two right here, these two angles are still a linear pair. Alright, so if this is 116, 180 minus 116, alright, 64 degrees would be this side. Alright, so if you had to find JK, J to K would be twice as big as the 64. That's the 128 again. Alright, so that was an angle on the circle. The third theorem you're going to have to know this week is on the bottom of 743. 3 different situations, but in all 3 different situations, the angle formed by the secants or tangents is outside the circle. Alright? So you've got this situation. You got a secant and a secant. They form an angle outside the circle. You could have a tangent and a secant. The angle formed is outside the circle. You could have 2 tangents. The angle formed is outside the circle. Alright? So, when the angle formed is outside the circle, the angle equals 1/2 times big arc minus little arc. Okay? The angle equals 1/2 times big arc minus little arc. So if we call this ABC, and then D and E, the measure of angle A is going to be equal to 1/2 of arc CE minus arc BD. The angle is equal to 1/2 times red minus blue. The angle formed outside the circle is equal to 1/2 big arc minus little arc. The angle formed outside the circle, again, it's outside the circle, so it's 1/2 times big arc There's your big arc minus your little arc. So a couple of examples. Start off with two tangents. Two tangents here. Let's go ABC. You're given a 102. Arc AC is 102. And you're asked to find the measure. Find the measure of angle B. Alright, the measure of angle B. So this angle right here, it's outside the circle. The measure of B is going to be equal to 1/2 times big arc. Here's your big arc. That big arc is equal to 360 minus 102. And 360 minus the 102 is 258. Big arc, 258, minus little arc, 102. Alright, so the measure of angle B is equal to 1/2 times 258 minus 102, which is 156. And half of 156, 78 degrees. Angle B. The measure of angle B, 78 degrees. The next way you'll see this problem let's go with a circle, a secant, and a tangent. But the angle formed is outside the circle. So if the angle formed is outside the circle, then the formula stays the same. So let's say this is 40 and this is 80. Alright? And you need arc AC. So we got to find arc AC. So here's the formula, or the rule, that the angle formed outside the circle, the 40, is equal to 1/2 times the big arc, which is AC, minus the little arc, which in this case is 80. Angle equals 1/2 times big arc minus little arc. So you divide both sides by 1/2. 40 divided by 1/2, it doubles it. So 80 equals AC minus 80. And you could add 80 to each side. So 160 equals AC. Alright? That arc out there would be 160 degrees. Make sense? Need to see another one? Ready for your assignment? Alright. Today, page 744. You can start on page 7. No, check that. Page 745 again. 745. Four through 6. Twelve through 16. And then 18 through 23. 18 through 23. Alright, that's your practice for today. Make sure you're checking the odds in the back of the book as you're doing the problems. If you get an odd problem wrong, come see me so we can figure out what you did wrong.